I hope all of you are doing good. Let's start today's chapter, Fundamental Geometrical Concepts. We shall have a brief revision of geometrical concept in this chapter. Geometrical concepts. Point. A point is an exact location. It has no length, breadth or thickness. In the given figure, A, X and M, these are points only. Okay. Line. The basic concept of a line is its straightness. This is a line. A line has only length. It has no breadth or thickness. It extends indefinitely in both the directions and has no endpoints. You already know that a line has no endpoints. Okay. Next is line segment. A line segment is a portion of a line. It has two endpoints and a definite length. Okay. Ray. A ray is a part of a line that extends indefinitely in one direction from a point on a line, say A. This A is called the initial point of the ray. Okay. A ray has only one endpoint and it has unlimited length. Okay. This is the ray. It's initial point. This point is the initial point and we can extend this from this side. Okay. Indefinitely, and it has unlimited length. Next is plane. A plane is a flat surface which extends indefinitely in all the directions. A plane has a length and breadth but no thickness. Infinite number of lines can be drawn in a plane to a given point in a plane. Only one line passes to two different given points in a plane. So, two different lines in a plane either intersect exactly at one point or are parallel. Next, space. Space is the set of all points in the universe. Hence, everything we look at is a part of a space. Next is axiom. Axioms are statements that are accepted as true without proof. Theorem. A theorem is a statement of mathematical truth which has to be proved from the facts already proved or assumed. A statement whose truth can easily be derived from a theorem is called its corollary. Okay. Angle. An angle is a figure formed by two rays or line segments with the same initial point. The initial point is called the vertex of the angle, about which you already know, and the two rays or line segments are called its sides or arms. Okay. See, this is the angle and these two are the arms. Types of angles. Acute angle. An angle whose measure is below 90 degrees is called an acute angle. Okay. About which you have also studied in your previous classes also. Right angle, an angle whose measure is 90 degree is called a right angle. For example, this is a right angle. Obtuse angle. An angle whose measure is between 90 degree and 180 degree is called an obtuse angle. Means more than 90 degree but less than 180 degree. Okay. For example, this is obtuse angle. Straight angle. An angle whose measure is 180 degree is called a straight angle. See, this is straight angle. Reflex angle. An angle whose measure is between 180 degree and 360 degrees called a reflex angle. Means more than 180 degree and less than 360 degree. For example, this is straight angle, your reflex angle. Okay. Now, more about angles. Number one, adjacent angles. Two angles are called adjacent angles if they have a common vertex, a common arm and their arms lying on either side of the common arm. Okay. For example, in this figure, angle AOB and angle BOC. These two angles are adjacent angles because they have a common vertex which is okay. If the sum of two adjacent angles is 180 degree, then their exterior arms are in the same straight line. Okay. In the figure COA, here you can see this is a straight line. Okay. Number two, linear pair. Two adjacent angles are said to form a linear pair if the sum of their measure is 180 degree. Okay. The sum of these two angles is 180 degree and these form the linear pairs. Number three, complementary angle. Two angles are called complementary angles if the sum of their measure is 90 degree. Each angle is called the complement of the other and complementary angles need not be adjacent angles. Next is a supplementary angles. Two angles are called supplementary angles if the sum of their measure is 180 degree. Each angle is called the supplement of the other. Supplementary angles need not be adjacent angles. And five, angles at a point. Consider the given figure. The four angles meeting at O add up to 360 degree. This is true no matter how many angles meet at a point. The sum of angles at a point is 360 degree at a point. Okay. Number 6, angles on one side of a straight line. Okay. Okay, so here is a figure given to you. Okay, so the three angles together make a straight line. As you can see, angle 1, angle 2, angle 3, and these three angles are making a straight line, right? So this is true no matter how many angles make a straight line, the sum of angles at a point on a straight line is always 180 degree. Okay. 7. Vertically opposite angles. When two straight lines intersect each other, form four angles forming two pairs of vertically opposite angles. In the adjoining figure, see 1 and 3, 2 and 4. These are two pairs of vertically opposite angles. Okay. Theorem on vertical angles. If two straight lines intersect each other, then the vertically opposite angles are equal. Given. Okay. Two straight lines A, B and CD. A, B and CD intersect at the point O. So we have to prove angle AOC is equals to angle BOD, means this angle is equals to this angle, and angle AOD means this angle is equals to this angle, that is angle COB. So proof statements. Number 1, angle AOC plus COB is equals to 180 degree. Reason, AOB is a straight line and sum of angles at a point on one side of a line is equals to 180 degree. Number 2 is angle COB. Okay, this is COB plus BOD is equals to 180 degree because angle COD is a straight line. Okay. Then from 1 and 2, angle AOC plus angle COB is equals to angle COB plus angle BOD. Okay. Reason from 1 and 2. And for angle AOC is equals to angle BOD, since a COB is common to both sides. Okay. So similarly, we can prove that angle COB is equals to angle AOD. Now, example. Let's take an example. An angle is 1/3 of its complement. Find the two angles. Okay. So let the angle be. We don't know the angle. Let the angle be x. Okay. So what is given here? An angle is 1/3 of its complement. Okay. An angle is 1/3 of its complement. See, first angle is x, another angle b, second angle, what would be the second angle? 90 minus x. Okay, degree. So 1/3 of the complement. So here 3x is equals to 90 minus x. 3x plus x is equals to 90 and 4x is equals to 90. X is equals to 90 upon 4. Okay, so what will you get here? 22.5 degree. Okay, so the value of angle is x and the another angle is 90 minus 22.7, that is 67.5 degree, right? Exercise 19.1. Two complementary angles are in the ratio 5:4. Find the angles. Okay. So we don't know the angles, but we know the ratio. So let the angles be. Let the angles be 5x and 4x. Okay. And these are complementary angles. So the sum of these two angles will be 90 degree. 5 plus 4 is 9. 9x is equals to 90. X is equals to 90 upon 9. That is, the value of x is 10 degree. Now put the value of x in both these angles. 5 into 10 is 50 degree and 4 into 10 is 40 degree. So these are the two angles which are in the ratio of 5:4. Students, now you will do practice of the remaining questions.